Morning and welcome you all to this session. I hope I'm audible to all. Uh, Welcome you all to the webinar today. It's on generative AI and prompt engineering. My name is Anju Pandey. I'm going to be the speaker for this session today. And with that, let's get started. Right. So today's webinar is going to be primarily on covering the concepts of what is generative AI and talking about different aspects in generative AI, talking about prompt engineering, Hugging Face API, transformers, and working with OpenAI API as well. So here we go, and let's get started. In general, uh, the world has been already exposed to the concept of AI. So AI, the conceptual idea to AI began back in 1950s, 60s, where we started, the word AI. The word AI was actually coined, and since then, slow to fast, there has been multiple developments till date. Right, people started talking about AI quite a lot in early 2000, and since 2010, as the computing capabilities became quite low cost and the data availability became quite easier. AI was there, happening forward in every industry. Right now, ideally, AI talks about or AI is about making computers being able to act as intelligent as human in some capacity. For example, if you've been using Google Translate, it does as good as job as human when it comes to translating languages or speaking multiple languages. When it comes to if you've been using Apple Face Lock, it does facial recognition as we humans do. We recognize our friends and family members. Those are multiple examples of AI in general. One of the segment of AI which has gained quite a lot of popularity in last few years is machine learning, right? Which is where again machine learning was coined back in 1997, and here we talk about the set of algorithms which use data to develop intelligent solutions. Right. So ML is the subset of AI where we leverage data to build intelligent engines. And finally, then deep learning. In last 10 years, deep learning has flourished like anything. And that's a segment of machine learning. You can say a subset of machine learning techniques, which is where the algorithms can learn what to learn from. They can perform automated feature engineering to solve complex problems and work efficiently on unstructured data such as images, text, and audio. So today, modern day advanced solutions we've been looking at, such as self-driving car to Google Translate, face recognition engine to object detection models, all of them backed by deep learning algorithms. And in last 5 years, a lot of development has also happened in the space of generative AI within deep learning. Now, all the developments except generative AI has been primarily upon using AI to build solutions which can discriminate between multiple engines. For example, if we talk about classification, we train a model to be able to discriminate between maybe a cat or dog or a spam or not spam email. And in recent 5 years, development started happening quite a lot in the space of generative AI as well, which is where the intention is to develop the intelligent capability which can help in generating data, right? So Gen AI is a segment which is where we intend to develop solutions which help in generating data. Data can be images, so generating images, generating text, generating audio files, generating videos, all of it. And all these solutions, all the techniques within Gen AI are actually derived from many deep learning algorithms. All the deep learning algorithms are primarily derived from neural networks. So that's where all the Gen AI techniques are derived from neural networks. And that's where technically, if you have to locate generative AI somewhere in this map, the best option would be to locate it within the space of deep learning. So you can think of the set of techniques which are used in generative AI. Those are all modified or varied, a different set of variants of deep learning algorithms. So if you have to start from to learn about generative AI and talk about how generative AI solutions are actually being built today, the origin is deep learning algorithms. You'll have to start with understanding fundamental deep learning algorithms such as transformer models, generative adversarial networks, and then coming up to how are these used to develop generative AI solutions. So that's a quick high-level context around what exactly is generative AI and where does it fits into the whole AI technological segment. If you have to further define generative AI from the context to what it is, the answer would be well. It's a subset of machine learning or deep learning algorithms. So it broadly falls under machine learning. Even deep learning falls under machine learning, which can help in creating content. Right. The whole objective is to build a model to be able to create content. So if you have to differentiate between the two primary components, one is discriminative AI. Here to the AI system, we input data and we get intent. Whereas if you have to explain generative AI, it would be we build AI systems where we feed intent, such as I need to have an image of a handsome looking man like me. And then you generate get data, which could be images, audio files, text files, scripts, anything of that sort. So that's about generative AI. That's how it differs from the modern day solutions that we've been developing so far, in the space of AI, machine learning, and deep learning. And this sense of being able to, sense of making intelligent solutions, being able to generate content, is actually again replicating the component of human intelligence, which talks about creativity, right? Where humans can create content, like the intelligence there with artists, content creators, right? The human creative processes. This opens a new set of opportunities for the world to look into what can be achieved with the help of Gen AI, such as automating multiple processes where human involvement is required to generate, validate, automate, moderate content or data. Similarly, the automating processes which require human creativity at fronts. So those are all possible situations where generative AI can play a very critical role. So that is about what is generative AI. Let's get into depth of this and talk more about it. Some of the applications of where it is being used today. Well, in last 4 years, in my experience, the world has been on their toes to look into possible applications of generative AI and identify where else can we leverage this. And today, generative AI is very, very widely being used for content generation. Almost every organization, whether it is into technology or non-technology business, healthcare to banking, finance to e-commerce, oil and gas to manufacturing, all of them have started to leverage generative AI for content creation, content moderation, and supporting their marketing, sales to business management, customer service team with a lot of data. Generative AI has been quite like poster boy of the world of AI adoption for creativity, automation, and cost reduction from multiple operational roles. Content creation has been one of the most successful application of generative AI today, widely being adopted in the market. In my past experience, I have helped multiple organizations with collaborative digital building applications on generative AI. So we've been doing multiple solutions where uh, we automate marketing funnels to marketing pipelines, where generating content helps to reduce a lot of effort and time being put in experimenting different marketing campaigns. Besides this, the other worlds where there's a lot of opportunity and there's going to be huge disruption with generative AI includes virtual world creation. The whole world of metaverse, right, and the virtual world can be actually automated, can be actually created at a very faster pace with the help of generative AI. The imagination can be converted to reality at a very Godspeed rate with the help of generative AI. And that's happening. That's already there in progress in this experimentation and development level. Besides this, Gen AI is widely being used for tasks such as music composition, designing art and design, generating a lot of images today. So now buying image licenses is no more a concern in the market, right? Organizations are preferring to use generative AI over having to buy licenses for images and copyright, getting into copyright issues. And that's where it's actually disrupting the market quite a lot. So these are some of the wider applications, how Gen AI is being adopted, is being used across the world today. Let's talk more about it. Now, one of the component of generative AI is language generating text. Now, before we get into that, let's look at some of the examples of amazing generative AI solutions or platforms. Well, so far you would have for sure explored multiple solutions, including ChatGPT, right? So ChatGPT is one example where you can actually use that for content creation to content management, right? Let's see one example to it. And I'm sure today out of all attending the webinar, uh, almost 95% of you would have at least consumed ChatGPT and would have tested it for once. And now, with the recent enhancement in ChatGPT, DALLE is also integrated within that. And that brings, again, a world of opportunities. For example, ChatGPT is so easy that it helps in generating a lot of content. For example, if I have to write a script to create a poem, so I can get started. Hey, you are an expert in writing amazing poems on technical topics. Write a poem on generative AI. Give language and words simple, easy to understand. Keep the poem up to 6 lines. And here we go. Now this has generated a standard poem. So today, platforms like ChatGPT, Bard are widely used across the market. Character GPT as well, widely used across the market for multiple content generation platforms. And there are many platforms evolving today, which are leveraging further OpenAI, ChatGPT, and Google generative AI capabilities to develop amazing solutions. Another example could be create an image or generate an image of a human explaining generative AI. So it's going to go ahead and create an image around that. So these are examples of what are Gen AI platforms. Gen AI is all about. You feed intent to the engine and engine generates content or data. Unlike discriminative AI solutions where you feed data or to get intent out of it. Here's an example. That's about what's possible with generative AI or some examples of generative AI solutions. Now, one of the core component of generative AI, centerpiece of the generative AI, central focus of the generative AI segment is language, generating text. Let's understand more about how exactly text generation happens and how do you go about generating text and how exactly language model works. What is Chat GPT for that reason? What is GPT in that Chat GPT and what is T in that GPT, which stands for transformer? So let's try to evaluate and understand each component of the generative AI for text. To start with, first word that we need to get into is what is language model? Language model can be thought of as a computer program which understands language like we humans do. We humans understand language quite an effective way. If I give you a terminology such as maybe, what do you mean by terima kasih? Now, maybe some of you may not have heard of this term or word, but you all know this actually. Terima kasih is an Indonesian word which means thank you. Now, the moment you hear of that, this is thank you, our brain quickly relates to that. Well, these are the contexts I can use terima kasih. When I meet somebody from Indonesia and I want to thank them, I can always use the word terima kasih. Or else, if somebody says terima kasih, I can say welcome. Now, these are all different contexts that our brain has quickly created information about this new word in our dictionary, terima kasih. This is natural language model. We humans, when we speak multiple languages, we actually have a language modeling brain. And for each word that we know in our vocabulary, we have contextual information stored. For example, for thank you, you have contextual information stored as in when to use thank you, what to do after thank you, what to do before thank you, and so on and so forth. What is the alternate option of thank you in different languages, such as Indonesian, terima kasih, right? The language model in context to it AI is almost the same thing. It's about developing a similar language model as a computer program. So, a language model is a computer program which can understand human language like humans do, which actually has contextual information for each terminology in its vocabulary. These language models are quite effective in multiple complex tasks, such as, as we know human languages, natural languages such as English quite well, or maybe other languages as well, we humans can translate quite effectively. We can summarize, answer questions. So In general, computer language models are also used to perform those tasks. Language models are used for tasks such as translation, summarization, question answers, all of it. There are different ways to develop language models. One of the most popular way in recent years that has emerged quite a lot is transform models. Transformer is an approach which is the most advanced approach today to develop language models. And if you heard of Chat GPT, T in the GPT it actually stands for transformers. So today, majority of the advanced language models that we use, such as GPT, are actually built on the top of transformer. Let's understand what exactly is large language models and then talk about transformer in detail. So from language model to large language model, think of a person who only speaks one language compared to that. Think of a person who speaks multiple languages and has quite a good knowledge about terminologies in all of these languages across different spaces such as technology, maybe telecom, banking, finance, all of it. That means that person should be having pretty good idea to multiple terminologies across different segments. And that's where you can say that's an example of a bigger language model. So large language model is a language model where it is having information about multiple set of terminologies in the form of vocabulary, right? So these can be starting from the contextual information stored for those size large size vocabularies can range from 100 billion parameters to almost 175 billion parameters. Standard language models are, or small language models are having parameters up to 100 million parameters, whereas large language models have up to 175 billion parameters. That shows how large language models are. Some examples of large language models include GPT-3, T5. The complexity of large language models improves or makes it capable of solving complex problems, right, in natural language, such as performing state of art, language translation, summarization, conversation, coding as well. Multiple advanced solutions such as GitHub Copilot, Microsoft Copilot are actually built on the top of large language models. As we discussed, large language models are actually built on the top of transformers. What exactly is transformer? Well, I'm not talking about a movie Transformers. That was an amazing movie actually, which eventually also relates to AI. Well, here also a transformer relates to something similar, but not like a humanoid robots. Transformers are a set of techniques in na- neural networks which are widely used to develop language models. So they are deep learning algorithms which can be used for handling sequential data. Primarily, when we say sequential data, we refer to text data. Natural language is often sequential in nature. For example, each sentence that I speak has a dependency on what was the previous sentence that I used. That's where a conversation, maybe a text or email, every language, written in any language, is actually an example of sequential data. So transformers can actually learn quite effectively from sequential data, such as text data, and perform a pretty good job in tasks such as translating text, summarizing text, question answering. How are transformers actually built? Let's understand that as well. Transformers are primarily built on top of encoder-decoder architecture, which is widely used for neural machine translation to question answering agent as well. So transformers are actually built on the top of encoder-decoder architecture, where it uses encoder to convert, let's say, if it is about language translation, Spanish to English. So encoders are used to convert Spanish into a context vector, and decoders would use that context vector to convert it back to English. So encoder decoder architecture are quite widely used for developing state of art complex NLP solutions today. Now, within encoder decoder, in order to enable encoder decoders to effectively generate context vector and leverage context vector, the concept of attention mechanism is used. Attention mechanism was first proposed by researchers at Google back in 2018, and then it kind of blew up the world, right? So that's why it became quite popular and almost everyone started using it. So large language models are actually built very widely with transformers, right? And yeah, transformers are primarily trained with huge amount of text data to make it, work and understand, process human language, natural language. Let's take here an example to understand transformers a little bit more effectively. Well, for detailed understanding, we'll have a course in which we can get into depth of it. A quick idea to transformer could be here. Here's an example. There's an example of what happens actually in attention model, right? So here's an example of transformers. Think of this as encoder. An encoder will take maybe multiple words in a sentence. And for each of the word, generate a context vector. That context vector will again be scored, and an attention decoder will generate the sentence in another language using that context vector. For example, as you would see that here we have a a sentence in Spanish. The sentence in Spanish is the sus vident, right? For each of word, the encoder RNN is generating a context vector. And then these three context vectors are fed to decoder. Decoder using the context vectors are generating the sentence I'm a student in English. So input is Spanish and output is, that's an example of what happens in attention model. And transformers uses mechanism. So transformers are primarily built on two concepts. One, encoder decoder architecture like this. Encoders simply are responsible for generating or converting text to vectors, whereas decoders use those vectors to convert it back to text. GPT is actually built on the top of all decoders, multiple decoders bundled together. And BERT, which is a very popular large language models by Google, is built on the top of merging multiple encoders together. Now, whenever you ask any questions to ChatGPT, the ChatGPT uses encoder to convert your question into a context vector. And then that context vector is fed to a decoder engine which generates text. So how informative your question is, based on that, the context vector is going to be formed, and context vector is then going to be used to generate the text using decoder engine. That's how ChatGPT works. Now, there's a lot more to talk about, or we can discuss about what exactly happens in RNN. It has a hidden state which helps in generating or learning from sequential data. The context vectors go through the process of attention mechanism, in which it uses self-attention mechanism to provide weights to each of the context vector, and accordingly, certain vectors are going to be key drivers of the overall contextual information. That's about transformers, right? Now, with the help of transformers today, widely large language models are built. There are some of the large language models which are already available open source for free to use. And in industry, in order to develop LLM solutions, instead of training a large language model from very scratch, we actually go ahead and use some of the very popular large language models. So if you want to get into the space of generative AI and natural language processing, maybe you can go ahead and understand large language models and understand what are the top most popular already pre-trained LLMs and how do we use them to actually develop enterprise solutions. Training a large language models from very scratch is a very expensive job. It requires huge amount of data as well, which at times becomes difficult and very complex to develop the same. And that's where, to save the computational resources as well as data for the gathering efforts, we make use of pre-trained LLMs which are trained by huge amount of data already. And that's where some of the very commonly used pre-trained LLMs include GPT, generative pre-trained transformer, based on the transformer technique, developed by OpenAI and very popular engine for text generation. BERT, bidirectional encoder representation from transformer. BERT is actually used in the backend of Google search engine to enable Google search perform advanced AI-based search and map the contextual relation of your query to all the available internet websites. And similarly, T5, text-to-text transfer transformers, 5 times T, right? So that is also by Google and a very popular text-to-text transformer engine, right? And so yeah, that's an idea. Now, all of these models you can use by two different ways. One, you can leverage them by making use of APIs. OpenAI, Hugging Face provide you different APIs via which you can access these pre-trained models directly. Second, you can fine tune or customize them using frameworks such as TensorFlow, PyTorch, and Transformer from Hugging Face. They allow you to access the pre-trained models and fine tune them on custom data set as well. That was about pre-trained models. Some of the popular applications of LLMs include, again, LLMs are widely used today across different market segments. In marketing, marketing sales are some of the very leading segments where LLMs and generative AI is widely being adopted. Generating personalized product recommendations to creating compelling stories or slogans, launching marketing campaigns are some of the key use cases in marketing. Whereas ability to process huge amount of text data, extract insights from it, develop testing and develop new drugs and vaccines are some of the key use cases where science and medicine segment industries are focusing on leveraging generative AI at the moment. Whereas finance is already using generative AI to process huge amount of text to predict the market trends, market sentiment, and forecast risks and trends associated to any stock. Finance is also using generative AI to improve fraud detection and prevention as well. Today, modern day organizations are using generative AI to complement some of the NLP models and directly use generative AI with prompt engineering to resonate with pre-trained NLP solutions for different use cases such as sentiment analysis, entity recognition, and many more. This was about language models and understanding to it. Now, one of the very popular way to consume large language model is where you can go ahead and use Hugging Face API. Hugging Face API allows you to access multiple pre-trained models. The symbol is actually a logo of Hugging Face API. If you haven't ever tested Hugging Face API, I would strongly recommend you to go to Google and search for Hugging Face API. You can actually find out multiple models available for multiple segments over Hugging Face platform, such as multi-models, computer vision models, pre-trained models for natural language processing, audio, and tabular. You can leverage these pre-trained models which are already available, such as this is an example of pre-trained model by OpenAI, right? Whisper Large Tree, that is for audio transcription. You can also use pre-trained model for a variety of different tasks here as well. An example of using Hugging Face model could be here. To use Hugging Face model, we can first install the transformer library. So here we go, and install the transformer library. Hugging Face already provides you multiple options. For example, if I were to use Visual Large 3, I can go to this model and it provides you pre-written code to access this. For example, if I click on use in transformer, as you can see that I have pre-written codes by which I can access this. Here's an example to do that. As an example of using from transformer model, we are downloading the auto model sequence for classification, auto tokenizer as well. Here we specify the model name is distill bird. So bird we already discussed, right, bidirectional encoder from transformers. But base uncased, that means it understands capital and small differently. So we'll go ahead and download that model and tokenizer and specify the task that we want to perform sentiment analysis. Define the model as model, tokenizer as tokenizer. And let's say we want to give a text. Hugging Face is an amazing company. That's a positive sentiment. Let's see if we download a model and can we use pre-trained large language models to perform sentiment analysis for us. It's just you need to specify which model that you want to download and for what purpose do you want to use it. So in the pipeline, we're specifying that we want to use it for sentiment analysis. Now it goes to Hugging Face and downloads the pre-trained models, right? For example, this model is of 268 MB and now it's downloaded. As you can see that it says label as label 0. That means it is, you know, false sentiment, right? And you can, there's a score associated with it as well. And I can say Hugging Face is a great company and I love it. Just to make it label 1, right? 0 is actually, can be thought of as referring to -1. So label is +1. Label 1 is like positive. And if I use it same for a different one, maybe I'll take pizza as it is bad for health. Although I don't hate pizza. Well, it should be actually. So you can see that as it is very bad for health, I may say. Right. And although the score is 50%, that means it's actually towards the 0. I hate pizza. It's bad for health. It is, not tasty at all. Something of that sort. Right. 51% is where it is, quite confused actually. And you can fine tune that with certain data to make it work even better. Another example of using Hugging Face API is for NER, named entity recognition. We can specify, the tokenizer as well as the model that you use. And for any given sentence, it's going to be able to do entity recognition. Here's an example where it downloads this model, DBMDZ, bird large cased. Now, this model is quite heavy. As you can see, it's 1.3 GB, but it's downloaded now. And let's see how effectively it does the job of entity recognition. We'll try one more task as Collabora. So you can see that Hugging Face is based in New York City. So it is able to extract information such as, at first it identifies HU, which is an organization. Furthermore, it identifies Hugging, right? It identifies Face, right, as an organization. So Hugging Face on a whole together is actually an organization. It says that way. Similarly, New and York, it is identifying New York as you can see, The entity is location. So it is identifying New and York together as location. Similarly, city is also part of the equation. So New York City is identifying it as location. Similarly, if you look at here, right, Collabora, right, Collabora. So it is identifying Collabora as organization quite effectively. Similarly, at the end, Collabora incorporation, you can say, right? Similarly, Open AI, it is identifying as miscellaneous. Furthermore, API as miscellaneous. Furthermore, America is identified as location. So it is able to extract different words and the what entities they represent. That's an example of using language models from Hugging Face API. So Hugging Face is actually a pretty popular platform for natural language processing, and it has multiple pre-trained models available. If you have to count out over Hugging Face Hub, you have more than 120,000 pre-trained models, and you just need to learn how to use them effectively and fine-tune them for different tasks. It also has 20,000 data sets, which you can use to customize models for certain specific tasks, and more than 50,000 spaces, that is demo applications available over Hugging Face platform. Hugging Face, today enterprises and engineers across the world are using Hugging Face API to develop state-of-art NLP solutions, such as text classification solutions for in order to develop solutions which can classify text into one of many categories, question answering engine, language translation engines, text summarization engine, and code generation engines as well. Here's an example of code for Hugging Face for text generation, sorry, text classification, which you already seen. And similarly, you can use it for entity recognition and many more. That is about large language models and how we, one of the way to access them via Hugging Face API. Let's now shift to the another super interesting component, which is where we talk about the concept called prompt engineering. Now, one of the way to consume generative AI engines, large language models, is to do prompt engineering. If you remember, we were putting one of the question, or you can say an input in the uh, model, that was an example for prompt. Whatever I wrote in the ChatGPT platform, that was also an example of prompt. So what is prompt engineering? Essentially, prompt engineering is an art of crafting precise and effective prompts to guide the AI models in generating desired output. So it's a way of crafting a prompt, a question in an effective way so that AI models can generate the right. So how good your prompt is, that qualitative results you're gonna get. A lot of people complain about they don't get good results with OpenAI or ChatGPT. It's just because the prompt is not that effective. Yeah, a lot of people across the world who are using ChatGPT and GPT engines in a super effective way to automate majority of their tasks, only because they use effective prompt engineering. So prompt engineering is about a process of selecting right prompts, writing and crafting right prompts so that you can get better results. If you have good prompts, it can help you get the most optimal results out of generative AI engines. Example of good prompt is prompt which is more clear, concise, to the point, and detailed. Let's talk more about prompt engineering in general. Some of the example of prompt engineering could be here. There are multiple techniques across prompt engineering, right? Let's talk about them. To test it out, we're going to use ChatGPT and we're going to use GPT actually, consume it via OpenAI API. For that, in Collab, I'm going to go ahead and install OpenAI library. Click install OpenAI. I have a specific key which I'm using that is giving me access or providing me access to OpenAI API. We're going to import OpenAI and say OpenAI.api key equals key. That is where we are configuring the OpenAI key. Although recently OpenAI has launched updated version of this SDK in which you have to create a client object and with the client object specify the key. Here we're creating a function which is generate content, right? Feeding the prompt as input and model as GPT 3.5 Turbo. The GPT model uses a specific format for messages, so we specify role, user, content, and prompt completion. So now we are, using the OpenAI API. So say OpenAI.chat.completions.create, and that's going to simply create. So if we're configuring OpenAI and specifying key with it, and we're going to go ahead and simply use a function called generate content. In this function, we are specifying model and the message format where we are putting up prompt as the role user and saying OpenAI.chat.completions.create, pass the model and messages, and returning the response from the model. So let's say if the question is, if the prompt is write a Python code to print hello world, and that's where it's going to take this question to GPT engine, GPT 3.5, and generate code. So the code is print hello world. Now there are multiple techniques in prompting. We can spend quite a good amount of time in talking about it. But let's go ahead and look at a few of the important techniques. One is zero shot prompting. Zero shot prompting is where you don't write an example, right? Directly pose questions in terms of this is a question that I want to get answer to. That's an example of zero shot prompting. For example, I went to market and bought 10 apples. I gave 2 apples to the neighbor and two to repair my. I then went and bought 5 more apples and ate one. How many apples do I remain with? Let's think step by step. So here's an example of zero shot prompting where we are not providing examples of questions and answers to the model. And you're just providing a question where you would want the model to generate an answer to that, right? Where you're not guiding the model how to use, what approach to use to answer the question. That's where we call it zero shot prompting, where you don't provide any example, any reference, you directly ask questions. In a lot of cases, we all do this, right? We all go for zero shot prompting, but well, that's not the most effective approach. So it's going to simply use this prompt and generate answer this question, right? Let's wait for that. Quite a similar way, we can also go for few shot prompting. Few shot prompting is a scenario where actually we provide context in terms of what is to be done. For example, your task is to answer in a consistent style. Teach me about patience. We are providing example. If the question is teach me about patience, the answer is patience is like waiting for whole day to see moon in the evening and then sleeping after having a look at it. Right. That's an example where we're providing a question and an answer, and then we ask another question. Teach me about resilience. This is an example of few shot prompting, where you provide certain example to the engine and ask it to uh, generate answer for that. So it's going to simply go ahead and look at all of the questions, the context provided, and create a step-by-step solution to it. That's an example of what we refer to as future prompting. Let's look at the solution. This load is one of the challenge where you get bit of a load on the server. So here's an example. As you can see, step one, bought 10 apples, remaining apples are 10. Step two, give 2 apples to the neighbor, remaining apples are 8. Step three, get 2 more apples to repair my remaining are 6. Bought 5 more apples, 11, 8, 1, that is left with 10 apples. That's what it has given solution. Now, you do not provide, an example in terms of how to solve, and you expect the generative AI engine to solve it for you. That's an example of zero-shot prompting. Whereas few-shot prompting is where you already provide example. Via this, you actually set the theme of what kind of context and approach that you want to use to your answer. So as we can see that patience is like waiting whole day to see the moon in the evening and sleeping after having a look at it. That's quite a lot artistic approach to answer the question. The same way the engine has learned that artistic approach and answered resilience, as resilience is like a sturdy tree that bends and sways in the strongest of storms and remains firmly rooted in the ground, never breaking under pressure. That's an example of future prompting. Similarly, there are multiple advanced prompting approach. One more is chain of thoughts. Chain of thoughts is required, multiple examples or steps for the model to perform. For example, which is the faster way to work? Is it option one? Take a 1,000 minute bus and half an hour train and finally get the bike ride. Or take 800 minute bus and then an hour train and finally 30-minute bike ride. These are multiple options that you're providing to the model, and the model is going to have a think over multiple options, and after a chain of thoughts is going to give results that well, which option is the better option of these two. Would be there are multiple other approach to improve the prompt that you write so that you write and end up having concise prompt, which will give you better and desired results or the prompts sent to the generative engine. Here it has gone into general prompt where it has evaluated option two, and finally it says option two is the faster way to get to work with total time of 890 units. Let's talk more about prompt engineering. So some of the key elements of prompt include five. When you draft a prompt for any specific task, you can include these five critical components. First is role playing is setting a persona for the LLM to make it easier to consider certain approach while generating context. For example, you may want to set up a role that you are into an artistic role, or you are an expert in generative AI, or you are an expert in writing legal documents. Then provide instructions, that is what core exact task that you want the model to do. For example, summarize the following text or generate text for this. Context, you may want to provide some information such as consider the economic downturn or provide investment advice. Right. Set the context which model should consider when it comes to generative answers. And finally, in case if there is some important information that is to be used by the model, provide that as well. And then provide output indicator. What format of output do you look for? Should it be concise? Should it be how many lines? Should it be in a specific format? Like that. So these are some of the key elements of a prompt. That's great. Some of the very popular techniques in prompt engineering include role play, where you make the model act as a specific entity, such as historian, scientist, actor, director, architect. Iterative refinement, which is more about writing a prompt and observing the output and refining it in a recursive manner so as to achieve the best prompt output. Feedback loops to inform and adjust subsequent prompts in the prompt engineering segment. Similarly, we've seen example already for zero-shot prompting, few-shot prompting, and chain-of-thought prompting. These are also some of the techniques in prompt engineering. Furthermore, some of the best practices for prompt engineering include be clear, be specific. Your prompt should provide very specific instructions to generate your engine in terms of what to do. Be diverse in examples, provide multiple examples with different scenarios and context, and use an iterative process to evaluate, fine tune, and improve your end prompt. Right. Now, at the end, we'll talk about one of the very popular platform for generative AI, that is OpenAI. OpenAI has multiple extensions, including text generation. It also has extensions for image generation as well. So you can use OpenAI to generate images from scratch. You can use OpenAI to also create edits of the existing image based on a new text prompt. You can also create variations of the existing image as well. Besides that, these are some of the examples of code to create images, to create variation, images from scratch, right? To make edits in the images, like give an image and provide it a context. I may want to say that, a professional lady standing in front of an office building with a man. So here's a man in that space already put in. So OpenAI can do that as well. Or else generating multiple variants, give an input image. You may want to get variations of this image. So OpenAI comes with that as well. OpenAI is also effective for audio data processing as well, where you can use the Whisper engine for audio transcription. It can also do audio translation as well. It limitedly supports audio size up to 25 MB with specific formats such as MP3, MP4, MPEG, M4A, WAV, and WAV. You can use it to transcribe audio or convert it to multiple languages as well. Here's an example to OpenAI for images. We're going ahead and creating a client object, and we can say client.image.generate, generate an image of a lady in a professional dress in front of an office building. N equals 2 is to specify we need two images, each of the resolution 1024 into 1024. Now it's going to generate a new images, in fact, two new images for a lady in a professional dress. Here's where we got this. The URL for the images. We'll go ahead and download the images and plot visualize them up. So we are simply going ahead and downloading the images and trying to visualize them up. So here are the images that it has generated for the prompt that we provided as input. So that's an example of what you can do with OpenAI for images. Similarly, you can do it for audio transcription as well. That was it. Right. Now, this is where we are done with the completion of the segment. Now we are into the question segment. So yes, everyone, we are open for questions. Go ahead and ask questions in chat, or else you can use the Q&A segment as well. Go ahead. Yes, any questions so far, everyone? I hope you have enjoyed this webinar. Let me know any questions. You can also keep reaching us out as well for any queries and concerns, or else in case if you want to explore furthermore in generative AI, you can pursue some of the important courses to build your career further in this space. Right. For PPT, I think I need to check, right? I think you can get in touch with our collaborator team, Asia team. They can help you out with some details around it. For sure. For sure. So, Hugging Face API. So, this is a question. Is there any option to train our own model? Yes. Hugging Face API gives you an option to fine tune existing pre trained models available. So, with that, you can fine tune the models and create it, customize it for your custom use case with your data set. In fact, for your task, you can also download embeddings from OpenAI ChatGPT as well to create a custom solutions with the help of your data. So yes, that's doable with Hugging Face and also with OpenAI API as well, but with the help of multiple embedding generation models available. I hope that answers your question. Any other questions, everyone? But for the recording, you can get in touch with the Asia team. They should be able to help you out whether it is possible or not. We can do that. It just most of the APIs are built in Python and in Java, right? So for majority of the APIs, you would find primarily Python support available. Ideally, it is possible to do it with she hash code, but then Python is quite more popular, and that's where a lot of support and feasibility is available in the API. That is the case. But technically, yes, it's possible with different language as well. We can use, but Microsoft Azure has actually kept the OpenAI capability quite limited to only a specific set of people. So you have to actually send a request and get your specific subscription approved to use Azure OpenAI API. Right. And in fact, after that too, it is primarily designed for enterprise solutions instead of retail solutions. But besides that, for custom use cases, you can consider using Google Vertex AI engine, which provides almost similar situations or APIs for consumption. Right here. So in case if you're good so far, no questions, we'll take a pause. Thank you for joining the webinar. I hope you would have enjoyed it. Hope to see you further in upcoming webinars. Thank you.